Okay, folks, I hope you are staying safe and I hope you're not too bored at home. I want to do a video here and cover several of these questions on the battery circuit and make sure that we're all on the same page. So it might take me a couple videos because I haven't paid for the subscription for my video service, and so I can only do 5 minutes at a time. Okay, so first, first question says if you have a 9-volt battery on a circuit and you add a 9-volt battery in series, what is likely to happen to the voltage on the circuit? Okay, so first of all, I have a circuit here with one battery, and I actually have two lights on it in series. Both are 10 ohm resistor lights. First of all, if I measure the voltage here, it measures 0, you can see, which is kind of weird because unless you really understand what you're measuring with voltage, it seems odd because if I move the red probe over to before I go into the light, it still measures 0 volts. But if I measure after I go into the light, now I have 4.5 volts. So first of all, when you're measuring voltage, what you're really measuring is the difference or the potential difference between the 2 points, this being the point where the black probe is and the point where the red probe is, the potential difference between the voltage at those 2 points. So it's a little bit weird to think about. That's why, even though there's electricity flowing over here and we're using this, we're not eating up any of the voltage. There's not a potential voltage difference there, which is one of the reasons why, like if this was a power line and say a bird landed on there, the potential difference between the 2 points of it where its feet are on the line is not very big. It's basically 0 voltage. So because there's 0 voltage difference there, for all intents and purposes, for our purposes, there's basically 0 difference. That's why a bird would not be electrocuted. It's not because it's not making a circuit, because it is making a circuit. It's because the potential voltage difference is basically 0. So if you look at this, first of all, I have 9 volts here total in the battery. I'm going to use up 4.5 volts in the first bulb and another 4.5 in the second bulb to make a 9-volt potential difference. Okay. So I'm using up half of the difference in each of the 2 bulbs. Okay. So if you think about that, it would make sense if I'm also in series. Okay. I'm going to put a battery in. So here I had a drain in series. Now I'm going to have a potential source of more electricity in series. So if I go before, when I went from one side of the battery to the other side of the battery, I had 9 volts potential difference. Now I have 2 batteries. I have 18 volts potential difference. And when I come down here, so it's doubled, it's added together, just like the drains on the voltage added together. As I come down here, it's still 0 like it should be. There's no potential voltage difference. I come to the first light, and instead of using up potentially 4.5 volts or half of the voltage, I'm now able to use up 9 volts or half of the voltage there. If I go to the next one, now I'm using up potentially 18 volts because I use another 9 volts there. If I moved the black probe down to here, I'm using up 9 volts here. If I moved the probe to here, I'm using up 8 volts because I'm going through both of those here. I'm using up 9 volts. Okay. So that's the difference in the voltage when you put the batteries in series. Basically, you're adding, when you put the batteries in series, you're adding together the voltages, just like you subtract the voltages or you add the potential drains on voltages together when you put resistors or light bulbs in series.